ladies and gentlemen. We're going to work on part 2 of what you're going to need to do for your earthquake volcano activity. So we've started to plot some points, and we practiced that a little bit. And as you noticed, you're going to have to continue plotting the points that I have placed on here. So let's do Japan, for instance. So Japan happens at 32 north and 138 east. So we know it's going to be in this particular area because it's positive and positive. So Japan is 32 north, so here's 32 approximately, and 138 north. I'm sorry, 138 east. So here's 135. Notice how I'm taking my pencil and curving. And I need to go over just a smidge because it's 138. So it's going to be approximately right here. Now it is an earthquake, and its depth is 345. So I am going to label this and make it green. Now, ladies and gentlemen, I did not write the plates that were involved here, so you're going to need to write those in there. So when I look at the plates, here's the Pacific plate and here's the Philippine plate. They both seem to be involved. You might even want to put the North American plate. So I'm going to write those in. So I'm going to put NA for North American, Philippine, and Pacific. Now the next ones that you're going to do are volcanoes. So make sure you use a triangle as your symbol, and make sure you write the plates that are involved. Now notice you don't have to worry about depth and magnitude because we're worried about the type of volcano. So now your task is to find 18 more earthquakes and 7 more volcanoes. Now I have printed out some packets that have information about the latest earthquakes and the latest, most recent volcanoes. You could use those packets, or what you could do is I have some websites that were listed, and you could also use one of these websites. Now, if you look at the seismic monitor, you'll see that things are popping up right as you watch it. The pink have happened in the past 5 years, the yellow in the past 2 weeks, the orange yesterday, and the red today. So let's say I wanted to put these on my informational data sheet. Well, this is how it works. Let's say I'm interested in this one that happened today. If you pull it up, it will actually give you the magnitude and the location. But if you click on it, it'll zoom it in a little bit for you. And when you click on it a second time, it gives you all the information about either that earthquake or one that's happened basically in the same spot. So it gives the location, it gives the latitude and longitude, the magnitude and depth. So everything that you need to fill in your data table. You may also use the printouts that I have. And they involve the same thing. The latitude, the longitude, the magnitude, the depth, and the location, which will be your region. You can kind of ignore the event, and this just gives the date and time that it happened. The same thing for volcanoes. There are websites online that I have in your packet you can use, or I've made a list and printed out the most recent volcanic activity. Notice, obviously, we don't have as many volcanic eruptions as we do earthquakes. And when you're looking at that earthquake website, you'll actually see them pop up in front of your eyes. So again, you need to find 18 additional earthquakes and 7 volcanoes. Now when you're doing your earthquakes, many times they happen in the same area. You want to make sure that you're having data where it happens all over the world. That'll make your job easier for the next step when you start answering your questions. So speaking of the next step, once you have all your data plotted and all your data on your data table, The next step is to do a little bit of problem solving. So you're going to use your map to answer these questions. Now when you get to number 3, you're going to use a world topographic map. I have one in the very back of my room, or you could also go online and look at a topographical map online. So what that's going to ask you to do is, let's say you're looking at an area where there was a whole bunch of earthquakes. So say right in this area. You're going to match this area with the topographic map and notice what natural boundaries there are. So let's try that. See if I can find one online. That we could use. These are excellent, but they don't necessarily give me the information. I think I need one labeled. I'm not finding what I need. Well, unfortunately, I think we're going to have to use the one in the back of the classroom. You're looking for natural boundaries. That would include any types of ridges or mountains or trenches, anything that would be in that area. Now once you're done with that particular portion, you're going to move on to a plate boundary map. And I've done this for you. So all you really need to do is use the one that I've done for you. I've taken a picture of it and I put it on Moodle, or you can use the ones in the classroom. So you are going to label with orange the convergent boundaries, blue the transform, and green divergent. Make sure that you put this key on your map key as well. So then you have some more information to answer the questions once you have this information. And then you're going to draw a conclusion. So you go back to your original question. Do the locations of earthquakes and volcanoes on Earth create a pattern? It says refer back to your original hypothesis and use evidence from this activity to support your decision. Use ABC paragraph form to write your conclusion. So you'll need to do that. The last thing you'll need to do is you need to research some of the effects of earthquakes and volcanoes. Now obviously earthquakes and volcanoes affect all the spheres. Atmosphere, which is air, hydrosphere, which is water, geosphere, which is land, and biosphere, which is living organisms. You're going to need at least 2 for each sphere. So let's say you do some research and you find that volcanoes emit a lot of carbon dioxide. That would be biosphere. This carbon dioxide can suffocate humans as well as plants, believe it or not, because plants still need oxygen. So